The phenomenon of magnetism. Materials can be broadly divided into two classes, that is, magnetic and non-magnetic. However, from the microscopic electronic theory of magnetism, substances are classified based on certain important magnetic properties. The phenomenon of magnetism has been known since ancient times. The mineral lodestone, magnetite, an oxide of iron which has the property of attracting iron objects, was known to the Greeks, Romans, and the Chinese. When a piece of iron is stroked with lodestone, the iron piece itself acquires the ability to attract other pieces of iron. The magnets thus produced are polarized, that is, each has two sides or ends called north-seeking and south-seeking poles. Like poles repel one another and unlike poles attract each other. In physics, magnetism is one of the phenomena by which materials exert an attractive or repulsive force on other materials. Some well-known materials that exhibit easily detectable magnetic properties are iron, some steels, and the mineral lodestone. However, all materials are influenced to greater or lesser degrees by the presence of a magnetic field. Objects such as a bar magnet or a current-carrying wire can influence other magnetic materials without physically contacting them, because magnetic objects produce a magnetic field. Magnetic fields are usually represented by magnetic flux lines. At any point, the direction of the magnetic field is the same as the direction of the flux lines, and the strength of the magnetic field is proportional to the space between the flux lines. For example, in a bar magnet, the flux lines emerge at one end of the magnet, then curve around the other end. The flux lines can be thought of as being closed loops, with part of the loop inside the magnet and part of the loop outside. At the ends of the magnet, where the flux lines are closest together, the magnetic field is strongest towards the side of the magnet. Where the flux lines are farther apart, the magnetic field is weaker. Depending on their shapes and magnetic strengths, different kinds of magnets produce different patterns of flux lines. The pattern of flux lines created by magnets or any other object that creates a magnetic field can be mapped by using a compass or small iron filings. Magnets tend to align themselves along magnetic flux lines. Thus, a compass, which is a small magnet that is free to rotate, will tend to orient itself in the direction of the magnetic flux lines. By noting the direction of the compass needle when the compass is placed at many locations around the source of the magnetic field, the pattern of flux lines can be inferred. Alternatively, when iron filings are placed around an object that creates a magnetic field, the filings will line up along the flux lines, revealing the flux line pattern. Magnetic forces are fundamental forces that arise from the movement of electrical charge. Maxwell's equations and the Biot-Savart law describe the origin and behavior of the fields that govern these forces. Thus, magnetism is seen whenever electrically charged particles are in motion. This can arise either from movement of electrons in an electric current, resulting in electromagnetism, or from the quantum mechanical spin and orbital motion of electrons, resulting in what are known as permanent magnets. Electron spin is the dominant effect within atoms. The so-called orbital motion of electrons around the nucleus is a secondary effect that slightly modifies the magnetic field created by spin.